Okay. Oh, yeah, cool. Why we do this? Maybe yeah, this is my colleague Jackie and myself. We're going to share with you about Kubernetes cost optimization. Hands up if you like Kubernetes. Hands up. Continue hands up if you enjoy day-to-day operation for Kubernetes. Not many people with hand, right? You are not alone. Kubernetes, there are some challenges, right? Introduce our friend John. In the morning, City office asking, can you please predict our cost in the next 6 months? Next 6 months, how do I know? At lunchtime, developer thinking, why my application running so slow? Can you please help? People call me. At afternoon, his manager thinking, do you remember how far we are already behind the Kubernetes upgrade? Can you please upgrade now without downtime? Sounds familiar. People laugh. Because you can see, it's not easy. You have a request from different organizations. They ask for resiliency, performance, and also cost efficiency. Can I do that? Can I have a job? Where should we start? Today's session, I'm going to show you a practical example. One hand, we can maintain performance, resilience. Also, we can cost optimize, make everyone happy. Do you believe me? You are very tough audience. You are very skeptical. Let's prove that, right? Let me prove, not just about talk. Let's prove use real world examples. All right. Developer asks for performance. What do people normally do to optimize performance at all costs? What do people normally do? I need help. This is better for all of us, not for me.
Give it more CPU.
Give more resources. Oh, hardware. I need large nodes, right? I need big GPU nodes. More
Efficient code.
efficient code. I like that because every solution starts from application, right? That's pretty much you get lots of benefit. Typically, you're right. Once you get performance all the time, people tend to over-provision. Over-provisioning a size of the pods, probably not very efficient code. Over-provisioning hardware efficient node, or you have accessory, lots of replicas. You have a bigger size or more. So this is a challenge we typically see is very common pattern for design performance. When I say performance, I shouldn't put this too early. You ask for something, right? So let me introduce my first workload we need to deal with. Probably that's one of my friends. I may not like him or like the person, but I need to still cater for that demand. This friend name is called greedy. Greedy workload always asks more than they need. I don't like that, but I need to still deal with the demand. Greedy, which means for the resources you have requests and limit. Can anyone let me know why Kubernetes schedule the workload? Which one do you consider? Requests. Of course, requests, right? That's what it asks for. But be aware, there's some difference about scheduling and running, right? So it's two systems. Because Kubernetes basically take care of the request. But as soon as the task, the Kubernetes running inside running Linux, right? Linux groups. The utilization is basically handled by Linux itself. Kubernetes have no awareness at all. Basically, Kubernetes only care about the request when you schedule job. What does that mean? People tend to ask more than they need. That's what I say greedy. I don't mean to say you can ask basically what business need. Do you really testing, right? As a platform engineer, we need to challenge what default request or limit you put in. Don't just ask people to request whatever they need. We need to monitor what metrics we need. What metrics? We need to manage utilization. Fully understand, is it empty? Is it overutilized? Okay. Can you tell me this one? Already answer. This is a request. This is a limit. But you can see that line. That's utilization. This one is under request. What could happen? Can you tell me what's the consequences for underutilized on the provision?
Performance.
Reliable performance, of course. If you under provision CPU, what could happen? CPU throttling. But even worse, if you under provision memory, what could happen? Yeah, also memory, it kills. Basically, the power will be terminated. Right? So we need to be careful for that. But today's lesson is we address the next challenge, which is opposite. Over provisioning. You can set that line always below the request. What can we do? Right? So we definitely want to do a proper sizing. This example, real world example. People ask for CPU and GPU. This is a node with 2 CPU with 8 gig memory. Right? But this pod developer requests for 800 M CPU and 3 gig RAM. How many pods can this node accommodate? Only 2, right? I cannot put one more because it's only full. Because you also need to take consideration about reservation, right? The allocable resources is less than 2 with CPU and less than 8 gig. How about we right size, reduce the request and the memory? So this is result. Can see the difference? Right? You can have even 6 or 7 or a lot more just by right sizing. Because it's very important that gentleman mentioned, you need to start from application. If you don't right size up front, even if you can do lots of scaling from those level, you still not optimize. So very important to start the right sizing first. The question is how? Yeah, it's easy to show the picture. How do you find the sweet spot? Can anyone help me? What do you do with right sizing? We can handle the microphone if we have another one. Yeah, anyone want to volunteer? How can we find the right spot? What should we do? All right, if no sound, I wouldn't talk.
Load test it and see what it is under peak load.
Load testing. That's super important. Load testing in the dev testing environment, but also continue load testing in the production. Because workload change all the time, right?
Can monitors use it and then adjust?
Can you speak up? Use the microphone, please. By the way, this is a group conversation. Don't talk me.
Constant monitoring,
Yeah.
you use it and then adjust accordingly.
Fantastic. Monitoring, you're basically monitoring lots of metrics, right? What tools do we normally use to monitor these metrics?
Datadog and
Yeah.
L.
Yeah, you have lots of tooling to help you to capture the what has been asked and what's utilization. You can have also third-party Goldilocks, have also tooling to monitor the utilization.
I think I was gonna say similar, I was gonna say sort of like shrink wrap it, like just try and reduce down how much you're getting until you find out when it's getting in trouble.
Yeah,
In your test environment.
yeah. Sorry, if I understand, is that a comment or question? Sorry.
So I was answering your earlier question, what might you do? You might lower the amount of allocation you give to them and sort of like try and find their spot where that's up to price. So
Yeah,
shrink wrap them.
Yeah. If you ask that much, let's get around into the testing and shrink. Yeah, based on utilization and see how it goes. How? I follow the question, how are you going to shrink? People say, I'm running this environment. You tell me I'm asking too much. But that what benefit for me? I may got some disruption for my application, right? Yes, we have also tooling third party. And can everyone tell me the magic word? Start with V. VPA. Okay. What's VPA? You can say this basically scaling, right? And number two, bottom, which means VPA mechanism already in the Kubernetes, you can expand or shrink, right, on demand. But VPA has some challenges. Anyone know what challenge could be? Cost? It doesn't cost that much. VPA. Availability, yes. Before Kubernetes 1.33, VPA, you need to restart the pod, disruption to the pod. After 1.33, there's a new feature. Anyone know that feature? In place upgrade, which means VPA can integrate with in place upgrade without restart. It's still better version. It may not work on time, but keep one eye on this feature. VPA will be more compelling than before. So you can do that right sizing, right? Use VPA, but also third-party tools as well. We talk about VPA is about pod sizing, right? We go vertical. Another one is, I already mentioned that, HPA, right? Go horizontally. VPA is about size. HPA is about number, right? Based on your request coming, let's scale out or scale in. What do we do? What metrics we use for scaling? Anyone? CPU or?
Queue size.
Lovely. Did a rehearsal with you? Yes. CPU memory is good metrics because you can do reactive thing. But most time, customer already underperform, have performance degradation before you see the metric from CPU or CPU. You're right. Let's think about the business. How about the transactions? How many transactions come in? If you use some event-driven architecture, how about your events? How many in-flight topic in the queue? This is good metrics, very meaningful metrics, even customized metrics. But question is, by default, it doesn't support also customization, right? You need a different way to do that, which is Kata. Another way you can integrate with your HPA to do that meaningful metrics scaling. Okay, having said that, we talk about scaling about workload. Do you think that's enough? I have a HPA or VPA. We are good?
No,
You did rehearsal. You read my mind. Yes. How about nodes? Okay. This topic I'll hand over my colleague, Jackie, to handle that. Next one.
Right. Thanks, Frank. I think you mentioned about pod scaling, and that's where you should always begin because that's where you can get the maximum savings. But once you've achieved that, the next part comes as infrastructure scaling. And many times you have different teams handling these two. The pod scaling is more of a developer persona, and then the node scaling is more of a infrastructure or platform engineering persona, right? Now, how many of you have been using cluster autoscaler for node scaling? I assume all of you, right? And how many of you have heard about Karpenter? So Karpenter is an open source initiative for those who are new to that. So before Karpenter existed, we had all pod scaling, autoscaling, like Frank mentioned, is VPA, HPA, that basically lead to a situation where in a cluster you have pods which are unschedulable. So these autoscalers like cluster autoscaler or Karpenter, they keep monitoring for this status. And if let's say there is a breach window of 30 seconds, and then they start launching new capacity or new nodes to allocate capacity for these pending pods. Now, if you are, because we are from AWS, obviously I'm going to talk about how EKS works in this scenario, but similar thing applies to, let's say, AKS or GKE, any Kubernetes orchestrator. In this case, if you're using cluster autoscaler with on AWS, it talks to our intermediate API called autoscaling group, which is also known as managed node group, or if you are coming from Karpenter world or node pool, right? Now, autoscaling group is an intermediate step and then finally talks to EC2 fleet API. Now, Karpenter basically bypasses that, and you don't need cluster autoscaler because it can do provisioning and scheduling both for you, right? It simplifies that, and the benefit is you can launch capacity really, really fast because it's talking to the end API directly. Now, some of the benefits of Karpenter, obviously, we're talking about cost today. So cost definitely is associated with the time taken to, let's say, allocate that pod, right? If it's taking longer time to launch capacity, you are wasting time. So Karpenter it came from the initiative of application first, so coming a bit more closer to developers, where developers decide that, hey, I need this much request, and that's my pod sizes, give me a best fitting node, right? And if you have multiple replicas, let's say I want to bin pack together and get the best node, right? And that's what Karpenter does. It will give you an instance which can fit all of those pending pods together, if possible, and give you the best fitting node. And that's where you save cost. And you're coming closer to developers. You are not relying on infrastructure where platform engineering team already launched the instances, and they are, like Frank showed earlier, that could lead to over provisioning or under provisioning, right? So application first approach really simplifies that. And also, obviously, I'm going to talk about how you can save cost more than bin packing, more than best fitting by using different purchase options, different CPU architectures. Let's say you can use Graviton instances, which save up to 20% over Intel instances if you're using on AWS. And I think the equivalent ARM64 architecture exists for different cloud providers as well. Right? So you can bring different CPU architecture in the same node pool. And also you can use different purchase options like spot instances and RIs, and you can get different purchase options, right? And that's where you save more cost. And the cost is higher when you don't optimize for nodes, right? You can optimize for pods, but if you don't optimize for nodes, your cost will be much higher because that's where the actual compute cost comes, right? I briefly mentioned about how you can use different purchase options and different CPU architecture in a single node pool. And here's an example, quite straightforward one, where you are using, let's say, different different instance families like C and R. And just by saying CMR, Karpenter will not ask you to size them. Let's say, give the sizes beforehand. So based on your pending pod and how many total requests you need, how many total size you need, it will launch the best fit instance for you. And you can mix, in this case, I'll mix Spot and on-demand both. And a lot of people who have been using Spot, they know the challenge that if Spot becomes unavailable, what should I do? Right? And Carpenter solves that. So it's not that it's going to do the fallback for you. It's basically in a different way. It prioritizes Spot first. And for some reason, let's say you get insufficient capacity error, or let's say you get some other error, and maybe your Spot pool is too limited, then it will automatically launch on demand for you. Obviously, it cannot do reverse. Let's say you are running on demand, then I want to go back to Spot because Spot is available. In those cases, you can do manual intervention like using descheduler or some other mechanism. But this is how you save maximum cost by bringing different CPU architecture like Graviton, 20% cheaper, and then using Spot on top, bringing cost further, let's say 60% down. And that's the best you can do, right? Now, there's another great feature in Karpenter, consolidation. Now, if you're coming from cluster autoscaler world, I think it's a similar concept that exists. But how many of you know about consolidation and what does it mean? Anyone can answer. Right? Or maybe I'll ask in a different way. How many of you see that your cluster is over provisioned or there are nodes which are idle or underutilized, costing you money? Right? Have you seen that scenario? Right? Like most of you have seen that, right? Now, in this case, what Karpenter does is it will keep monitoring the state of your cluster. And let's say if there is a node which is idle, then you can just kill that node because it's no longer being used. And if, let's say, a node is underutilized, what I mean by that is the pods which are scheduled on that node are, let's say, just taking 30% of the total node capacity. So Karpenter can basically, look for similar instances and build back these pods together on a single node. Now, if you're using a node which is, let's say, quite bigger in size, even after this, it can even give you a replacement node which is smaller in size. Right? So it doesn't need to be that, just bring other pods together on this node and you're good to go. If you think the replacement is a better option, it can get you a cheaper replacement as well. And that's where you save the maximum.
Just a question.
Yep.
So you're from AWS, correct? Yeah. So one of the challenges we face as a financial institute that how we can spread the nodes across all the available servers. Okay. Because the problem is that we have subnets and the Karpenter would choose. So we got 3 subnets. So let's say we got a side range of like 512, and so the subnets will be like 128, 120, 256, and then if the Karpenter chooses to provision all nodes in the 126 side range subnet, what that means is that we ever run out of IPs, not only for the workloads, even in fact for the actual nodes itself. Have you got a solution for that so far? Last time I checked, we didn't have one.
I think maybe if I got the question correctly, what you're saying is you want to spread across multiple availability zones, right? Right. So there are multiple ways to do it. I think before even I go to cloud provider, within Kubernetes, there are like topology spread constraints. By using that, simple topology as availability zone, and you can say, I want to spread, right? And you can use on top of it factors like max, even Frank is going to cover that just in a bit, which can spread it either, very evenly, or you can spread it very broadly. What I mean by that is, let's say you want to have same number of replicas in each availability zone, or you don't mind that one AZ has many replicas and one has very few, right? So Kubernetes has ways to handle that scenario.
Correct. From the deployment side, yes, we can say that okay, this deployment has to be there. So but just in terms of like from the provider point of view, is there a way that people can figure out? I believe you're also mostly referring to how we can handle from using the MaxQ or the portable switches on the Kubernetes side.
So I think most of the orchestrators rely on the developer or on the platform or the users to define these criteria, because if we start imposing this within the scalers or within the provider, then it's not a great fit in many cases where let's say you're running a workload which should not go into multiple availability zones, because that could lead to, let's say, cross AZ cost, right? So if we start doing that, it wouldn't help in many use cases. So we leave it up to the end user to use Kubernetes constructs like, let's say, I mentioned for topology spread constraint and many other ways, right? To spread that evenly or restrict it as well. And I think Frank is going to cover that if you want to restrict as well.
Thank you.
Thank you. All right. So here, basically, I think exactly like what I was mentioning to him, where does it start, right? It starts with a developer where you start using, let's say, topology spread constraints, write labels to make sure that, you start planning for cost optimization at the development stage itself. Now, once you have done that, then a bit of a responsibility falls on, let's say, platform team who are managing nodes, or let's say Karpenter or node pools. And that's the place where you can mention, let's say, spot instances, Graviton, all sort of stuff, right? To save more cost for you. And finally, it comes to the cloud provider. But cloud provider, like I said, is a bit of a shared responsibility. If you have done the best part or your work in terms of development and also platform, then cloud provider can give you the best optimized solution. Now, quickly, I wanted to share this particular scenario, many customers ask that, hey, when we come from the cluster autoscaler world or autoscaling world, then I have many different managed node groups. Now, what should I do when I come to the Karpenter world, right? So our recommendation is always think of it, the Karpenter gives you flexibility, right? So if you have the flexibility, then why not use a single node pool, which can give you basically the best fitting and bin packing, right? So you don't need to over provision. And if you're having many different node groups or auto scaling groups, in those cases, each individual auto scaling group or node group, you might see there is over provisioning because the peak could be different for different workloads. But when you come to a single node pool or Karpenter world, it takes care of that for you, right? So you see lesser and lesser over provisioning and much more cost optimization. With that, I won't take much time. Back to Fran. Thank you.
Any questions about this? You all agree? I'm surprised, you all agree. What you just said, they all agree about you, with you about the share, right? Anyone have different opinion? Okay. I don't really, are you probably handle the, this?
So this is a sort of naive question. I don't do Kubernetes.
No, that's no naive question.
But I like this consolidation. Like this is a notably NP-hard problem. Like it's impacting its own knapsack problem. So can you just put Karpenter in a corner and like make it hurt? Like, do you understand what I'm saying? Like if you try and pack optimally sized objects into containers, that's the knapsack problem. That's an NP-hard problem. And I would imagine that there are fleets of these things that are large enough to hit up against the upper limit. Is it just, do we know how it works under covers?
It's an open source project, so definitely you can look at it how it does. But it basically just looks at, it's not looking at actual utilization of, let's say, CPU utilization. It's just looking at how much resources you have allocated to that pod, right? It does a basic simple math at how many pods are running on the node, and it sums up how much requests you have defined there. And based on that, if it sees if it is underutilized or overutilized, right? That's how it does.
So I get the impetus, but the question is like, so then you have some number of pods that you could, like you use the word optimize. So that's the danger. If it's just going to do something, that's fine. So it's heuristic or whatever. But if it's going to like optimally pack pods into nodes, that's a problem. That's an NP-hard problem. So I'm just curious, like, have really huge fleets, can Karpenter just get driven to the wall, like trying to compute an optimum, or is it just some trick? It's heuristic. So.
Yeah, maybe we'll catch a bit more offline to get
If you understand your question properly, is can we have some magic? Don't worry about all this underlying terminology, just make it work. But we need to probably think about, is that what you mean?
I'm just saying, like, it seems to me it has a risk that it will have problems that are so hard for it that it will, just spin, trying to work out how to optimize that.
That's why we have jobs. It's so easy, everyone can do that. Put this way, for Kubernetes, it's an orchestrator system running on top of the Linux. There's two systems. Kubernetes basically you take care of the racks. What you ask for, I will allocate resource for you. In reality, what you ask for is not what you actually use. And workload demand change all the time. So you can think about this timeline. Kubernetes basically, this is what you want, I give you a bucket. Right? Basically, you start with probably like a bloom, right? Bloom is small, but during this timeline, the bloom could be really big, the bloom could be really small. What are we going to do? Kubernetes cannot do that easily because you need to rely on scaling mechanism. That's what you mentioned, Karpenter. Karpenter is very smart to do assessment while you have workload coming up, pending pod with adequate nodes. However, the workload change all the time. We really need a maximum to scaling, do a better big packing, or do consolidation to optimize the cost. So this is not one solve. There's no magic. The metrics is we need to monitor the metrics, continuously monitor that, and then continuously optimize. Yeah. But that answer your question?
Yeah, no, that's good.
Okay. But can you please handle the mic to Oleg?
It's okay, this is provider agnostic.
Yes, Karpenter has been an open source project, and basically Azure and Google also they can adopt that.
I've got a question here around the interaction between Karpenter and VPA and Kano, for example. You are optimizing your node by impacting as efficiently as you can, but then at the same time, assuming that you are also right-sizing your pods and you apply VPA on that, and you're also using CPU request and CPU limit, for example, would we expect to see that in a situation where everything is so optimized, is it using CPU requests for the optimization? And in that case, does that make the limit useless because everything's so packed together?
So Karpenter doesn't really look for limits, right? And that has been a challenge as well, because the best practice is to use, right? The best practice is to use quality of service. So basically size the request same as your limit. So you avoid a situation where you have many burstable pods, right? Because Karpenter doesn't account for burstable pod for that situation. It just looks at the request, right? So it doesn't really care about it.
So I think the follow-up then there is that you were talking about a dynamic strategy for workload request resource allocation, but now at the node level, you're using a static strategy for that. What are the interactions there, and how can we consolidate or reconcile the two strategies overall?
I think it does some of that on behalf of the user, right? So it keeps looking at, like I said, consolidation. That in some cases you basically see a situation where you are under provision, right? Then it will basically your pod will go into a pending situation. So I'll give an example, right? So you have a burstable pod which has taken more than what you requested, and if there are other pods which had lower priority, they'll be kicked out, right, from the nodes, because your burstable pod took more than it was supposed to. And like Frank mentioned earlier, it's a greedy workload, right? Now once they're kicked, then Karpenter will obviously keep monitoring those and launch new capacity for you. But in case there are pods which have higher priority than your greedy workload will be node provided more memory and it can get kicked out. So that's how, if you know the concept of quality of service in Kubernetes, you start sizing your pod where you give request and limit same, which gets the maximum priority for you, and those pods will not be kicked out in this kind of situation.
Thank you.
Thank you. More questions welcome. Let's continue on, but you can stop me. So thanks for the question about the resiliency, right? So basically this workload is, we call it a patch workload. Basically why it's a patch workload is I'm special. For some reason, I want to be available all the time and special. You can make that happen for me. But can anyone tell me what's the maximum we can make them happy from resiliency perspective? What's the maximum in the Kubernetes world? Improve the resiliency. Because you can have the pod having, node upgrade all the time. How you can ensure there's a minimize your disruption? Any mechanism? Anything can you think of? How about you will have an AZ failure? What can we do? You already mentioned that. Yeah. Everything fails. There's a mechanism called topology constraint. Topology spread constraint. You can set up different labels. You can set up AZ. You can set up different ways. For example, you have a special application. I just want to make sure I can cater for the AZ failure. If you have 4 AZs, I won't have my pod running on all 4 AZs, right? So that's pretty much the setup, like on the left. For this topology spread constraint, you have a value called max skew. What that means is the difference between adding apidays cannot be bigger than the max queue. On the left-hand side, if I set number with 1, the difference is 1. That's you can only afford, right? What that mean? If your workload is only need 4 ports, you have to provision more ports just because these constraints you need to comply. You need to spread your port evenly in all 4 AZs. Does that make sense? How about you talk with your customer or business? Yes, I understand you're special, but do you think you are really special like that? If you can spread your port to 2 AZs, would that be okay? Sure, I'm fine. In that case, you just increase one parameter from 1 to 3. That's what? Instead of spread evenly to all 4 AZs, it will be 2 AZs, right? 1 and 3. Because from AZ is 0, 3 minus 0 is 3. And I'm good. Just by this is real world situation, right? One of the largest unicorn in the world. We just help them to change that parameter from 1 to 3. We save them $1,000 per month. Sorry, per week. This is a very big number. If you have large requirement. Any questions about this? No? Okay. Does that make sense? Another one, how are you going to ensure this question? If you, in the event of upgrade of the nodes, how can you ensure you can minimize the disruption for the application? I need people to help me to find a mechanism. Kubernetes is an ephemeral word, right? Pod coming and pod start, pod finished. But my application rely on this pod. I'm special. I don't want to have lots of disruption. Can we maximize the availability of my application? Even I understand my pod will be disrupted. How can we do that? That's pod disruption project. People familiar with this concept? Hands up. Awesome. Thank you. What that mean? Can I explain that to the audience? What pod disruption budget mean?
It specifies how much disruption you can allow during a voluntary disruption event.
Wow. Your message is very succinct, voluntary, but sometimes it's basically there's no choice. You have to, but voluntary is we need to respect PDP. On the left hand side, can you tell us, explain what happened on the left hand side? Sorry, I overload my speaking to you. Can you explain to other people what happened from the left hand side?
Just trying to read the whole thing, putting me on the spot here.
Sorry, didn't mean that hard to me, but you can see it's 3 nodes,
Yeah.
right? What happened with the third node on the rack? What happened?
The third node goes down.
The third node is
Your event is being blocked because you could not
yeah,
your PDP says you can only have 1 unavailable,
yeah.
but then you can't reschedule it.
That's a familiar scenario when you're trying to patch your clusters. If you have this kind of like a port disruption button, you would face this problem, and you're trying to just patch and you're trying to go the offline, name offline one particular node, and your patching could be disrupted, and you could be stuck without the what do you call patching your clusters. Honestly, we have seen that.
Yeah.
You're a bit safe to say, same problem.
Exactly. Disruption happens all the time. When you do patching, when you have new AMI, you need to upgrade the nodes. When you have, in this case, I want to consolidate. The third node on the rack, I only have 2. It's lots of waste space. I want to consolidate it, but because you set up PDP too strict, I cannot. You set up PDP is 1, I have 2, I cannot. But I highly recommend you challenge, or I wouldn't say the word challenge, invite your developer in this journey, right? Set up the default PDP properly based on business need. Don't just overly constrain the PDP. By simply just increase the number from 1 to 2, guess what? On the right hand side, you can evacuate, right? You can restart these 2 pods into the existing node. What's the outcome for that? You can terminate that third node. With 1/3 of saving. So just by simply change that parameter. Does that make sense?
Doesn't that make the assumption that you cannot reschedule the pod? Because assuming that you can reschedule the pod, Kubernetes would still be scheduled one by one until that node is empty, and then that node will be deleted.
So this happen is basically Karpenter will do the assessment, right? Karpenter understand this third node is underutilized, and we comply with the PDP and we evacuate. Right? Basically, this 2 pod will get restarted. So this is a Karpenter will also assess, find a home. Because we do the assessment for existing node, we have space, right? We have space, so we can just instead of provision a new node, let's focus on conservation. Based on workload, we'll find a home and make optimize, increase utilization. So these 2 nodes, existing 2 nodes, will be enough to cater for five pods. So does that answer your question?
I think so.
Okay, probably not.
Maybe you have a chat later.
Okay, good. All right, so this is about past workload, right? You are special, but we can make you feel special, but still cost optimized. One more. We have also the workload is very chatty, right? Maybe one of the overlooked costs is cross-agent charge. So what would happen? This one is people familiar with this ALB controller concept, right? When you set up ALB controller, basically you can set up 2 modes. One mode is instance mode, which means all the traffic from ALB you need to go to node port first, and from node port we'll find your target port. It could be in the same ALA, it could be in another ALA is massive. In this case, you have cross-AZ charge because you have traffic between your nodes cross AZs. Another option, this is legacy mode, instance mode. I highly recommend you pay attention to annotation for ALB controller and ensure you set up IP mode if you can. In this case, ALB will always send traffic to the same AZ. Right? So this reduces also the cross-AZ charge. Another one is about your workload already running your cluster. This is busy map, but you just focus on 2 things. One is you have microservices, you have client, you have server, right? Running on microservices. They running in a Kubernetes environment, they need to talk to each other. On the above, that paragraph means you don't have topology aware routing setup. You don't have that, which means the traffic will go everywhere, go to any ports across all the AZs. But at the bottom, this one, we have the setting configured, and it will try to find the same port in the same AZ, find a port in the same AZ to reduce the traffic cross AZ charge. Does that make sense? Oh, I think that's pretty much my content here. But like I said, this is a journey. This is not just one stop. We need to work along with many other personas in the company. Work with your developers, be friendly with them, right? And then understand the business requests and continue to evaluate that and adjust. And we need to work with them together to right size. We can, if a platform engineer, because we don't have that awareness about business requirement. When you work with the budget owner, to better understand how to make them, give them visibility about the cost, use lots of dashboards to show them what they spend now and what potentially you can spend in the future. And this is a fun journey, but we have lots of levers you can pull. Like I mentioned, right sizing, mod scaling, and node scaling, and also you can optimize your cross-AZ traffic. So lots of things, and probably what I mentioned today, 15 minutes, is only, very tiny bit, but you are welcome to talk with us offline. I can show you more advanced, comprehensive, materials you can find out. Overall, we mentioned about drone, right? Happy word, we have so many mechanisms put in place, and hopefully you can like Kubernetes, but also enjoy day-to-day operation. Thank you so much. We are outside, and thanks for coming.